welcome to my math class. So in the previous lectures on limits, we studied about the concept of limits. Yes, the sin x by x function, what happens to it as x tends to 0. Yes, before that we studied about the sandwich theorem, and then we studied about indeterminate forms, L'Hospital's rule. Yes, today let us solve some problems on L'Hospital's rule. Yes, so I've written a problem here that says, okay, let me write down the solution. Yes, they are saying limit x tends to 0. Yes, limit x tends to 0 cos x to the power half, okay, minus cos x to the power 1 divided by 3 divided by, yes, sin square x. Can you simplify this in any, like, using anything? Now, what happens if I substitute x as 0? Yes, if I take the limit as 0, I would get cos 0, which is 1, and 1 raised to the power anything is 1. So I would get 1 here, minus again 1 here, divided by sin 0, as we know it is 1. So we are getting a 0 by 0 form. Yes, so using L'Hospital's rule, what would we get? Let's use L'Hospital's rule. Okay, so yes, so for L'Hospital's rule, we would have to differentiate the numerator. Yes, what is differentiation of, okay, y power n with respect to x? I would get, say y is a function of x. I would get n y to the power n minus 1 into dy by dx. Okay, so this is the formula. Now in the place of y, we have cos x. Yes, so let me write half, okay, cos x to the power, what is half minus 1? It is minus half. Yes, and then differentiate cos x, which is minus sin x. Yes, now again the same thing. I would get 1 divided by 3. What is 1 divided by 3 minus 1? 1 by 3 minus 1 is minus 2 by 3. Yes, so I would get cos x to the power minus 2 by 3 into sin x. Is it just sin x? I would have to change the sign over here, right? This divided by, okay, let me take the line. This thing divided by, let me differentiate sin square x. What would I get? I would get 2 sin x cos x. Yes. So now 2 sin x cos x is a trigonometric formula, right? So 2 sin x cos x is sin 2x. Yes. Should I substitute that now? You see, in the numerator, you have sin x, even here sin x. Yes, so if we are free from sin x, we have only cos x. Yes, so the limit is x tending to 0. So if you have sin x, only at that point you would get zeros, right? Because sin 0 is 0. But cos 0 is 1. So we have cos 0, and cos 0. So there is no point of getting indeterminate forms, right? So that is why I cancel the sin x. Okay. So what would I get? I would get, let me just apply the limits directly. Yeah. So I would get minus half. So cos 0 is 1. 1 to the power anything is 1 itself. Yes. So plus 1 divided by 3. The same concept. And then we have 1 divided by 2. Yeah. So if you take the LCM, what would you get? You would get Okay. So 3 2s are 6. Minus 3 plus 2. Yeah. So it is minus 1 divided by 12. So let me check where is, if we have minus 1 divided by 12. Yes, we have. That is option B. Okay. Moving on. Next question is limit x tending to 1. Yeah. Let me write that down. So before coming to conclusions, you first write the given question, observe what they've given, and then you plan correctly what to do. Yeah. And if you solve after that, it would be better that rather than rushing in. Okay. So we have 1 minus 2x plus x square. So if I substitute directly 1, what would I get? Log 1. Log 1 is 0. Yes. So I would get 1 minus 1, which is 0. In the numerator, I have 0. Yes. So in the denominator, I have 1 minus 2 plus 1. So I would get 2 minus 2, that is 0. So we would have to use the L'Hospital's rule. Yeah. So I would have to differentiate. Can you recall what is the differentiation of x power n with respect to x? It was nx power n minus 1. Yes. What is the differentiation of log x? Differentiation of log x is 1 divided by x. Right. So let me use that. X tending to 1. So we are differentiating the numerator. So differentiation of a constant is 0. Yes. Differentiation of log x is 1 divided by x. And differentiation of x is 1. Yeah. So again minus 2 plus 2x. Now if I substitute 1, I would get 1 divided by 1. So 1 minus 1 is 0 again. Yeah, in the denominator I would get again 2 minus 2. So again let me use L'Hospital's rule. Yes, that is I would be differentiating numerator with respect to x and denominator again with respect to x. Okay, so x tending to 1. So what is the differentiation of 1 divided by x? Yeah, so can I write 1 divided by x as x to the power minus 1? Yes, so the differentiation of x power n is n. What is our n over here? We have minus 1. Yes, into x to the power minus 1 minus 1. So x power minus 2. Yes, I'll write that as 1 divided by x square. So basically this is minus 1 into x to the power minus 2. So I'm writing that as minus 1 divided by x square. Okay. So what would I get? Differentiation of 1 divided by x is minus 1 divided by x square. Differentiation of 1 is 0. Divided by differentiation of minus 2 is 0 because it is a constant. And then differentiation of 2 into x is 2. Okay. Now let me substitute the value of x. Okay. Let me apply the limits. Yes. So on applying the limits, what would I get? I would get minus 1 divided by 1. Yes, I'll write that as 1 by 2. So the answer is minus 1 divided by 2. Let me check if there is minus 1 divided by 2 in the options. Yes, our answer is option D. So yes, our next question is limit x tends to pi by 3. Yes, 2 sine of x minus pi by 3 divided by 1 minus 2 cos x. Let me write that down. So in the place of x, what happens if you substitute it as pi by 3? Yeah, or if you apply the limit x tending to pi by 3, what would you get? Can you check? Yes, I would get, I have 2 sine. In the place of x, if I put pi by 3, I would get sine 0 over here. Yes, and in the denominator, I would get 1 minus 2. What is cos pi by 3? Cos pi by 3 is half. So 2 and 2 gets cancelled. So I would get 1 minus 1, which is 0, right? So I would get, for sure, I would get 0 by 0 form. So what do? I would have to use the L'Hospital's rule. Yes. So how do I solve this? Let me differentiate the numerator. Yes, limit x tending to pi by 3. On differentiating the numerator, what would I get? I would get cos of x minus pi by 3. Yes, divided by plus 2 into sin x. Am I right? 2 and 2 gets cancelled. Yes. So what happens if I substitute the limits? I would get cos 0, which is 1. What is sin pi by 3? Sin pi by 3 is root 3 divided by 2. So I would get 2 divided by root 3. Yes. So do we have 2 divided by root 3 in the option? Yes, that is option B. Okay, so we solved 3 problems in this class. Yes, so what did we do in the first problem? We observed that we were getting 0 by 0 form. We differentiated the numerator. Yes, and then we differentiated the denominator too. We could have substituted 2 sin x cos x as sin 2x, but we did not do that. Why? Because we saw that sin x gets cancelled, and then after applying the limits, we got the required solution. Yes. So what again in the second problem? It was a 0 by 0 form. We used the L'Hospital's rule and we got the desired limit. The same thing with the third problem. Yes, that is it for today. Thank you.